Hello, welcome to my YouTube channel Janith Wanasinghe. I am here with the series Math Challenges and their solutions. Today, I am with the problem which will fascinate your enthusiastic minds. So, my question to you is 1 upon x plus 1 upon y equals 1 upon 252, where x and y both are integers. Find the number of ordered pairs of positive integers xy that satisfy this equation. Notice that my question is not to find the values of x and y. I am asking how many pairs of x and y which satisfy this equation if x and y both are in the set of integers. There could be a lot of answers if I consider x and y both to be in the real number set. However, I am considering only the integer set. So you can pause the video and then try the question out for yourself. And if you have succeeded and got a certain answer, you can check whether you have done it correctly. This is one method of solving this equation. There could be more. If you know another method, you can put it in the comment section. I appreciate that very much. If you are unable to solve this one, you can proceed through the video and learn how to solve this type of a question. Okay, I will proceed forward. Before that, I will explain you what a Diophantine equation is. A Diophantine equation is typically a polynomial equation containing two or more unknowns with integer coefficients such that the only solutions of interest are integers. So basically, the definition of a Diophantine equation removes out all the decimal answers possible for x and y. It only considers the integer answers, which automatically make this equation a Diophantine equation. If I consider the conditions one by one, it is a polynomial equation, as you can see. And also, there are two or more unknowns. There are actually two unknowns, x and y. The integer with integer coefficients, x has the coefficient 1, y has the coefficient 1, such that the only solution of interest are integers. So, I am giving you the condition that x and y both are integers. So, this is a typical example of a Diophantine equation. After knowing what a Diophantine equation is, you can categorize these types of equations to Diophantine equations and try solving using the algorithm I am going to teach next. Okay. So, first thing I am going to do is take the left hand side to a common denominator. That can be done by multiplying numerator by y and this denominator by y, and this numerator by x and this numerator by x, which make an equivalent fraction to both of them, and you can take them to a common denominator and write it like this. Then you can cross multiply 252 to the left side, xy to the right side, and expand the brackets and take all the terms to a single side. I have taken all the terms to left hand side. And then in the algorithm of solving a Diophantine equation, there is a certain way of writing a certain number as a product of two terms. Separately, we are trying to isolate each of the unknown terms. Otherwise, what would happen? You will end up with equations which contain two or more unknowns, but that would make our task very difficult. Therefore, I should find a way to contract this equation or sort of factorize this equation where the two unknown terms are separated at two places. So, the equation should be converted to a certain product type of a equation, and also the unknown terms should be separated from one another. So, to do that one, I am going to factorize this equation in a certain manner. I am going to add 252 squared to the both sides of the equation. You will see why I have done that in a moment. Now, if I factorize x out of these two terms, I am remaining with y minus 252. If I try to factorize these two terms with minus 252, I am left with y minus 252 again. That is the reason I have added 252 squared to the both sides of the equation. So, I have y minus 252 common factor in the left hand side. So, if I proceed through, I can write it like this. Take y minus 252 out and then write 252 squared as a product, y minus 252 times x minus 252. So, now I have written the equation as a certain product, and also I have separated x and y to separate terms. What I am going to do is, I am going to write this 252 squared as a product. It should be written as a product. So I can prepare two equations by corresponding this part to here and this part to here. Here there are two terms multiplied, here also there are two terms multiplied. In order to solve a system of equation with two unknowns, I need to have two equations. So if I equate this part to this part and this part to this part, I can have two equations. Now the problem is, what are the numbers which satisfy these two places? That is the thing. So if I can write 252 squared as a product of two numbers, which means I have to have the factors of 252 squared. But finding factors of 252 squared separately one by one is a very tiring process. Now if you have found two terms and substitute them here and then solve an equation and get an answer for y, again solve the equation and get an answer for x, likewise you have to do a lot of a process. Since I am not asking you the values of x and y, that would be very much useless. So we are going to use a method to obtain the number of factors which 252 squared has. So that is the pattern, or rather sort of an algorithm that I am going to use in order to find the number of pairs for x and y which satisfy the equation. So finding number of factors, do the prime factorization of the given number, express it as the product of primes, write the prime factorization in the exponent form, add 1 to each of the exponents, multiply all the resultant numbers. This product gives the number of factors of the given number. Now this is the algorithm to find the number of factors. Now let us see if this works to a certain number. Now let me consider something like 12. If I have something like 12, I need to do the prime factorization for 12. So if I am to do the prime factorization for 12, I need to divide this 12 by the prime numbers I know. So I am going to divide it by 2. I am going to get 6. Continuous division. Again 6 can be divided by 2. That would be 3. 3 cannot be divided by the first prime number. So I am going to go to the second prime number. That would be 3. 3 divided by 3 is 1. Therefore, I can write 12 as 2 times 3. But here, write the prime factorization in the exponent form. Therefore, I am going to contract this one as 2 to the power 2 and 3 to the power 1. So this is the way of writing 12 as a product of primes in exponent form. Next step is add 1 to each of the exponents. So one of the exponents is 2, the other exponent is 1. So add 1 to 2, that would be 3. Add 1 to 1, that would be 2. Multiply all the resultant numbers. This product gives the number of factors of the given number. Therefore, I am getting the answer 3 into 2, that would be 6. Now let us see how many factors are there for 12. So there are 1, 2, 3, 4, 5, 6 ways of writing 12 as a product. Because a number is multiplied by another whole number to get 12. So there are 6 such different numbers. Therefore, the number of factors for 12 is 6. So the number of ways the 12 can be written as a product is equal to the number of factors it has. So the same thing can be applied to the equation we have here. I will go forward. So 12 can be written as 2 squared into 3 to the power 1. So the number of factors would be, this exponent is 2, 2 plus 1 into 1 plus 1, that would be 6. So same thing happened here. Same answer comes. So if I can express 225 squared as a product of primes and convert it into the exponent form and use this algorithm to find the number of factors, then I can get the number of ordered pairs of positive integers that satisfy 252 squared. So if I solve them for x and y, I can get that much different answers. So if I go forward, I can write 252 in this manner. So if I square that I would get 252 squared, and I am having 252 squared as 2 to the power 4 times 3 to the power 4 times 7 to the power 2. I have the exponents 4, 4, 2. So 4 plus 1 into 4 plus 1 into 2 plus 1 would be the algorithm. Therefore, the number of factors of 252 squared is 75. So there are 75 different ways 252 squared can be written as a product. So each of those instances can be equated to these two terms and answers can be found. So the number of factors of 252 squared would be 75. Therefore, the number of ordered pairs of positive integers xy that satisfy the equation is 75. I hope you got a certain idea on how to solve this type of an equation using the algorithm I have taught you and the method of finding the number of factors a certain number has. So I hope you have enjoyed my video. So if you want to learn more about tricks in mathematics, special points in mathematics, I invite you to subscribe to my YouTube channel, like the video, comment, share the video, and that would be much appreciated. I will be back with another video very soon. Until then, good luck.